Okay, now we are recording. Welcome to the class again. There seems to be a question in the chat. Okay, yeah, there will be a short quiz at 2:30. Now it is published. You will be able to reach to that. That is more like a trial and error, probably, thing.
Hocam ya bir sanırım internet problemi var ama ilk derste de böyle oldu. Yani sanırım sizden kaynaklanma onu da bilmiyorum. Öbür derslerde çok olmadı ama sesiniz çok
Evet,
donuyor
bana da öyle geliyor.
ve ileri atlıyor. Bir anda hızlı geçiyor falan. Bunu nasıl çözebiliriz bilmiyorum.
Evet, ben de aynı şekilde oluyor hocam.
All right. Now the problem may be on my side, although.
Mesela şu anda dondu galiba.
Now are you hearing me? Can you hear me now? I will try to improve my internet connection within weeks. I purchased a new internet account, so once it is installed, probably and hopefully it gets better. But now, right now, I can't do anything further. So I will try to be a little bit slow, and I will try to continue with the explanations. Now, in the first lecture, we have classified the signals into several different categories. Some of them we can elaborate a little bit, which will be also an exercise for us to work about signals, to write signals, to try to draw signals and make sense of the signals. The first thing that you have to be careful about is the notation. The notation, what I mean by the notation is the continuous time signal is written with a parentheses, like this or like this, and the discrete time signals are notated with a square bracket. This is very important because if you use a parentheses and put an integer index, I get confused, and it probably means you are also confused. And their way of plotting is also critical. Continuous signals, this is too thin, sorry, let me increase the thickness a little bit. This, if you are drawing a continuous signal, x of t, on an axis of t, it is probably something like this. It's a continuously variation signal. Whereas, if you're drawing a discrete time signal, I expect from you to draw it like this, a bar with a full circle indicating the value of the discrete time signal, something like this, okay? In your book, if you check out the book by Oppenheim, you will notice how these are notated. And the index, the horizontal axis, is like this. Integers, -1, -2. And the values may be, I don't know, this may be 1, this may be 2, this may be 1.8. And you can indicate the values nearby each and every one of them, or you can put some legends here to indicate their values as well. So this is how, in general, we are going to draw things, and drawing things is an important thing. Now, let's think of a few example questions. What kind of questions can you expect? Today's quiz will show you what kind of questions you can expect. But there may be even more elaborated and difficult questions, even requiring proofs. For example, let's think of a question. It starts with a prove that. So let me write it. Prove that every signal x of t can be expressed as a sum of an even signal, let's call it x sub e of t, and an odd signal, x sub o of t. So does this question make sense to you, for example? When I ask this kind of a question, how will you approach? What does the question ask? Where is the question? The question is prove that. So you must make a mathematical proof. And mathematical proofs can be made only in one of the three ways. There are three ways to make a proof. One method is the construction. I may be disconnected, but no, okay, I'm online. So you start from the equation, you equate to something else, and you construct the result and show that this is correct. That is a method. It is called construction. That's basic proof technique. The second proof technique that you can use, not for this maybe, but for others, is induction. And induction, in the high schools, they don't teach them anymore. Induction is like this. You find the initial and trivial condition where the thing that you want to prove works. For example, for t is equal to 0, it works. Or for n is equal to 0, it works. And then for every n, it is supposed to work. You have to prove that. And the way to prove it is you assume that for n, it works. It's an assumption. You don't prove it. And from there, you prove that if for n, it works, for n plus 1, it also works. You prove the link. One link. There's an echo and I don't know what to do with that. I will try at 3 o'clock some different setup. Maybe because I am using two different sources, it is also difficult for the system to work properly. I don't know. Anyway, so you for the induction, you make an initial condition and you make sure that it works, and you make sure that the link also works. So with this initial condition and with this link, you may start from the initial condition and you can go anywhere. So for every n, it works. That's called an induction method. This is method number 2. The third method is contradiction. In contradiction, you assume that the thing that you are trying to prove is incorrect. You want to prove that it is correct, and you assume it is incorrect. And then you start construction. You construct with the assumption that it is incorrect. And at some point, you come to a contradiction. It doesn't work. And then you conclude that your assumption, which is saying that this is incorrect, is wrong. So what does that mean? It means it is correct. Believe it or not, in mathematics, there is no fourth method. We have only these three methods. So prove that every signal x of t can be expressed as a sum of an even signal xe of t and an odd signal xo of t. How do you prove that? By construction. This I will do. Construction. You say that let's have y of t, which is x of t plus x of minus t. Now this is an even signal because y of t is equal to y of minus t. If you say y of minus t, it becomes x of minus t plus x of t, which is the same thing. So I constructed an even signal, which is y of t. Then I construct another signal, z of t, like this, x of t minus x of minus t. And I say that this is an odd signal because z of t is equal to negative of z of minus t. Just substitute t with minus t. Z of minus t will be x of minus t minus x of t, which is the negative of the original expression. So z of t is equal to z of minus t. And if I add these two parts, I will have y of t plus z of t to be equal to 2 times x of t. Or I can equivalently say that x of t is equal to y of t over 2 plus z of t over 2. Okay. And if I subtract one term from the other, then y of t minus z of t will be equal to 2 times x of minus t. Or similarly, x of minus t can be written as this and this. But the real solution has already been found. It is here. What was the original argument? It was saying that prove that every signal x of t can be expressed as a sum of an even signal and an odd signal. And I have already done it. This is an arbitrary signal, x of t. It's not neither even nor odd. And it can be expressed as a sum of an even signal. Y of t was an even signal, so y of t over 2 is also an even signal. And z of t was an odd signal. So when I sum them up, I can obtain x of t. So I constructed x of t from its even and odd parts. It's simply saying something very obvious. Every signal can be split into its even and odd components. There are always even and odd components of a signal. I think I must have a new page. And we are running out of time already, so I have to be quick. For instance, let's say this is example. This is x of t. And this is t. And it's a function from 0 to 1 with a value of 1. And it's out of 0, 1 interval, it is all zeros. Is this an even signal? No, it's x of minus t is not equal to x of t. It's not even. Is it odd signal? No, x of t is not equal to negative of x of minus t. So it's nothing, it's just a signal. So what are the even and odd parts of it? What is x even and what is x odd of t? X even of t is x of t plus x of minus t over 2. That's something that we have already found. And x odd of t is equal to x of t minus x of minus t over 2. So how do we do that? X of t was this. X of minus t is this, from minus 1 to 0 with a value of 1, like this. This is on the same t-axis. So let me add them up, and I will have, and I will divide by 2, so over 2, let's say. It is from minus 1 to 1 all the way. 1s over 2 is 1 over 2. So this is the x even of t on the time axis. And the odd signal is x of t minus x of minus t. So we have to subtract the second one. Subtracting means making it negative and then adding, and it will be, and over 2, of course. So it will be 1 over 2 at the first half, from 0 to 1, 1 over 2, and it is negative of the flipped around version of itself, from minus 1 to 0, with a value minus 1 over 2 on the t-axis. So this is x odd of t. Are we happy with these two x even and x odd of t signals? Their summation must give us our original signal, this one, when we add them up. Do they give it? Yes, they do, because it was minus 1 over 2 for the odd part, for this part, and it is 1 over 2 for the even part in the negative time. So their summation will cancel one another, and it will give you 0, nothing here. And 1 over 2 from the even and 1 over 2 from the odd for the positive half will be added to give you 1, which is here. All right, so this plus this is equal to this. All right, now let's try, let's proceed with the examination. Let's quit at this point. You have a few minutes to log into Mergen and try to see that. And let's wait. I will let you try to read the question. The question is in the introduction part, not in the questions part. That was my mistake, and that's why I'm doing this experimentation. Let's see how it's gonna work out. Try to read the instructions carefully. There are two things that I ask from you. One of them is to submit the answers from the questions, but the questions are deneme and deneme 2. Sorry about that, but the questions are there in the introduction. And in the introduction, I also wrote the question, and at the end of the question, it says, try to upload your scan files to Google Drive, which I wanted to share with a writing permission as well. Let's try, okay? If you have any questions at this point, I will try to answer now. Otherwise, I will stop the recording. And yes, well, for the Google Drive, I would like you to use PDF, but if it is too difficult or if it's too much time consuming, just send JPEG, but the naming should be proper. Your ID number and your name and surname dot JPEG or dot PDF, whatever. Okay. JPEG is bad because the Google Drive link will appear within the question. The JPEG is difficult because there may be multiple pages. In multiple questions, you can answer them all together with several questions, with several sheets of paper, and you scan them one by one. So how do you combine into a single JPEG? Right? So my screen sharing has already ended. I'm stopping the recording.